All right, so part B, the last example I wanted to go over with you guys had to do with using implicit differentiation and finding a value at a specific point, but I wanted the implicit differentiation to be a little complicated, okay? I didn't want it to be something simple, something more that's going to challenge you to be able to use the skills that you should know, like chain rules and product rules and stuff like that, all together at one time, okay? So, like I said, it's just going to be one example, and that's going to be it. We'll be done with this section. So we're going to find the slope of the graph of and then here's the function for us. So 3 quantity x squared plus y squared squared equal to 100xy. So there you go, nice and complicated, right? At the point 3, 1. All right. So remember, we're trying to find the slope. Now remember, slope is a trigger word for derivative, right? Like that means you're going to have to take a derivative of this function. This is a pretty good function. It's complicated enough where you got to use multiple rules. And then once you take the derivative, then you're going to plug in the 0.31 to find the slope. Okay? So what I'm going to do is I'm going to take dy dx of both sides, or just d dx. Okay? So d dx of 3 of x squared plus y squared squared equal to d dx of 100 xy. Right now I'll start separating things, moving things out that we don't need. Okay? So that 3 in the front on the left side can be factored out. The 100 on the right side can be factored out. So let's go ahead and do that. So 3 d dx of x squared plus y squared quantity squared is equal to 100 d dx of x times y. So, I mean, that's the easy part, right? Just remove the things that are in the way. Now, let's start off on the left side where we're going to have to use the chain rule. Because notice, it's x squared plus y squared quantity squared, right? So there's a function within a function there. So when I take my derivative, now I'm going to start off with the power first. Okay, this is going to be the first thing that I look at, that power. I'm going to bring it down. So it's 2 times x squared plus y squared to the first. I know I normally don't like writing the power of 1, but just as an example, right? You got to subtract 1 from the power. And then I got to take a derivative of the inside. Okay? Notice there's no dy dx or dx dx or anything like that I had to write because I just took a derivative of a constant, right? I brought it down, right? The power just was brought down. Now I'm going to start doing derivatives of actual functions. So the derivative of x squared, that's 2x. Now since I am doing this with respect to x, right, I don't need to write any type of notification of, oh, I took a derivative of x with respect to x. I don't need to do that because that's the correct letter. Okay? But I got to do the derivative of y squared, which is 2y. And for that one, I have to mention that I took a derivative of y with respect to x. So after that, I'm done. There's nothing else that I really have to do with that side. Okay. Now on the right side, I have my 100. But my derivative of xy, that's a product rule. Okay. So according to the definition of product rules, you got to take the derivative of x first, which is 1. Y, no need to write dx for that. That's the correct letter. Plus x times the derivative of y is 1 dy dx. Now I do have to combine all of this stuff, okay, so that I can eventually get dy dx all by itself. So yes, this is going to be a terrible mess. Make sure that you're keeping your work nice and clean, okay? So let me do the following. Let's multiply 3 times 2 and then multiply that into x squared plus y squared. Okay, so that's going to be 6x squared plus 6y squared times 2x plus 2y dy dx equal to 100y plus 100x dy dx. Now I'm going to have to still keep distributing things on the left side because I'm trying to get dy dx all by itself. The right side is pretty good. There's not too much I can do there. Just kind of wait. But on the left side, I'm going to have to kind of multiply stuff out. So 6x squared times 2x, that's going to be 12x cubed. I'm just distributing, right? 6x squared times 2y, that's going to be positive 12x squared y dy dx. Now let's multiply with the 6y squared times 2x. That's 12x y squared. And then I am going to multiply 6y squared times 2y dy dx. That's going to be a positive 12y cubed dy dx equal to 100y plus 100x dy dx. The name of the game here is neatness. Okay, keep your work nice and neat. Now you notice there's a bunch of dy dx's. So what I'm going to do is I'm going to move them all to the right side. Okay, and I'm going to move everything on the right side that does not have a dy dx over to the left side. So in other words, this is going over, and this is coming this way, and that is going that way. So let me rewrite that. So I have 12x cubed plus 12xy squared minus 100y equal to, now let's move all the dy dx's, so that's going to be 100x dy dx minus 12x squared y dy dx minus 12y cubed dy dx. So I moved all the dy dx's to one side. It doesn't matter which side you choose. Just move it to some side, either right or left. What I'm going to do now is factor out the dy dx from all of those three terms. Okay? So I'm going to factor dy dx out. So 12x cubed plus 12xy squared minus 100y equals to 100x minus 12x squared y minus 12y cubed dy dx. What am I going to do with all of this? Yeah, I'm going to divide it. Okay? So here we go. I'm going to kind of flip my information. Okay? Dy dx is going to be 12x cubed plus 12xy squared minus 100y divided by 100x minus 12x squared y minus 12y cubed. That's your derivative. Remember, I told you it's going to be complicated. Okay? Enough with this x squared business. Let's get down to business, right? The way things actually tend to look sometimes. So, did I do any weird, tricky stuff? Not really. It was just a mess, right? That's all it was. It was just a mess. It was a lot of terms. But if I can just go back up really quick, notice I just had to do a chain rule on the left side. I had to do a product rule on the side. Now, the chain rule created a mess for us. Okay, but as long as I feel confident that I know how to multiply properly and distribute and stuff like that, I shouldn't be too scared about doing this. It's just going to take me a while. Okay, so that's what I did. I just started to distribute and distribute and distribute until I got just like a bunch of terms, right? Like right here. That's where I kind of said, okay, I got a lot of terms. What am I going to do with that? I probably should join some of these terms together so I can get dy dx by itself. Because remember, dy dx, that's my derivative, right? And derivatives mean slope. It means tangent lines, rates of change, right? We haven't talked about maximums and minimums, but that's in chapter 3. That's coming up. So I was able to kind of organize my work, factor out of dy dx, and then divide, and I found my slope. So all I have to do now is exactly what they wanted me to do in the first place, which to get dy dx and plug in for xy. What was it, a 1, 3 or a 3, 1? 3, 1, right? Okay. So plugging in a 3, 1. So when x is 3, y is 1. So 12 times 3 cubed plus 12 times 3 times 1 squared minus 100 times 1 divided by 100 times 3 minus 12 times 3 times, 3 squared times 1 minus 12 times 1 cubed. Punch that into your calculator, and once you're done, this is what you get. 13/9. Okay, that's going to be your derivative. That's your slope, I mean, not your derivative. That's the slope of that function at the point 3, 1. So that's it. That's the only problem I was going to show you guys. Like I said, I there's no way I could have done this last Friday. Okay, we didn't have enough time. Okay, so I'd rather just kind of take my time with it today, and from there, you should be able to, I think, do okay with it. It's just, again, it's not that the problems are going to give you are going to be extremely difficult. They're just testing you to see, do you know your processes, right? Do you know how to do a quotient rule, a product rule, a chain rule, power rule? Like, do you know how to do that stuff? And, if you can, then show them, right? Show them that you can. So let me give you guys your homework for this, and then we'll talk about the quiz.